Off with our parallelogram properties. Anywhere you want to go. Let's do this. Here we go, 14. Not here? Why do I have a feeling we're going to have a lot of not here's today? How about 10? 2 for 2. How about an 18? We're also lucky. Parallelogram property. Opposite sides congruent. Got it. Where else? Here we go. 16. Opposite angles congruent. Here we go. Next up. 2.
Opposite sides are parallel.
Okay, let me stop right there. What Will just said. I want to remind you guys, this is pretty important because if you have a parallelogram with a diagonal drawn in, what type of angles are going to be formed? Alternate interior. Remember that. Any diagram you're doing that has a diagonal drawn in, look for alternate interior angles because the sides are parallel. 2 more. Here we go. Rolling. 2 again. You're better than that. Come on.
Not say that diagonals intersect. Diagonals.
They do intersect. Most diagonals do in any polygon. Diagonals do intersect, and as okay, and you just went totally different way. Okay, whatever you got to do, right? And what about those diagonals, 10? Oh, great. Diagonal 7? There we go. And intersect, if you want to write that down, yep. All right, everyone all good? Properties of a parallelogram. Because what you're going to have to do today, I'm going to give you a quadrilateral, and you got to show me one of these 5 happens to make it into a parallelogram. All right, so I'm just going to give you a 4-sided figure, some information, and you guys got to show me opposite sides are congruent. Maybe you can show me opposite sides are parallel. Maybe you can show me the diagonals bisect each other to make it into a parallelogram. All right, I am not going to throw you into a proof right away. I just want you to do a diagram for each of the 5 ways to prove a quadrilateral is a parallelogram. Okay, so let's start with diagram 1. Both pairs of opposite sides are parallel. So draw yourself a little quadrilateral parallelogram looking figure and mark both pairs of opposite sides parallel. If you can do that, this is a parallelogram, and you're good to go with the proof. What if you can't do that? Well, can you mark opposite sides congruent instead? So if you guys somehow can get those sides congruent to each other, you have a parallelogram, you're done with the proof. If you can get, now this one's a little, I want to just focus a little bit more on this one than the other 2. Everyone see what I just did on my quadrilateral? Not good enough. Both pairs have to be congruent. Not a pair, both pairs need to be congruent if you want to use that one. Diagonals bisect each other. And I think you might want to just check if they intersect. Okay, that's always a good one. Right, Will? Got to have it, right? Can't bisect unless they intersect. All right. And now there's a new one, a special case. Some of you may relate. All right, there's too harsh, too soon. This is a little bit different, okay? I refer to it as the special case. Here's what it says. If you have a quadrilateral where one pair is both parallel and congruent. One pair, opposite sides, congruent, and parallel, you got yourself a parallelogram. Okay, so that's a little special case to watch out for. That's a little bit different than the properties you list for me every day. Okay? Questions about anything? All right, let's do this. I'm going to start with actually number 2. We'll go 2, 3, 4, 1. All right, 2, 3, 4, 1. Here's my diagram. I'm going to give you some information about it. Is it enough to say it's a parallelogram? And if you say yes, be ready to back yourself up. All right, so number 2, SX congruent to XT. So I know those two segments are congruent. And I also know SM and PT. Is that good enough, based on those 5 ways above, is that good enough to say that is a parallelogram or not? Is that enough information? Okay, what do we think? And if it is enough information, ready to back yourself up with one of the 5 ways. Is that enough information for me to say parallelogram? Here we go. 14, what do you think? 9 here. 9, what do you think?
No,
Why not?
because it doesn't follow any of the.
Doesn't follow anything. Diagonals don't bisect each other, and both pair of opposite sides are not congruent. So this is a no-go. All right, so this is not a parallelogram. Everyone okay, why? I just don't have enough info. All right, go to number 3. What do we got here? Ooh, PX congruent to MX. And you have SX congruent to TX. Enough information. Calm down, Mike. All right, calm down. Jeez. Here we go. 2, enough information.
Yes.
Why?
Diagonal bisect each other.
I'm telling you. Did I tell you or did I not tell you? The random generator finds it. All right? It may be random, but they find the person they need. So this is yes. And now I want to get you used to what we're about to write in our reasons column. Remember what we wrote yesterday? Flip it. What property are you using, Will? Diagonals bisect each other implies, what am I going to have it imply today now? I'm just going to pretend I didn't hear that. Parallelogram. All jokes today, jokes. About as funny as your grades. Oh, did I go too low? Too low?
No.
Too low? Sorry. Hop in. Everyone hop in the roaster. All right, it's going to be a long ride. Okay, next up. SP congruent to MT. And SP parallel to MT. Enough information. Now, I know it's not a property, and I won't call on anybody here, but do you see how this is our special case? Okay, so this is yes. And you can't write special case implies parallelogram, unfortunately. All right, but you can tell me, ready? One pair of, and here's the key word. You can't say one pair of sides, because that could be anything. It's got to be opposite. There's the key. One pair of opposite sides, parallel and congruent, imply a parallelogram. Be on the lookout for that one. Be on the lookout. Okay, I saved one for last because I didn't want the most confusing one to be first. SPX is congruent to TMX. Got it. And then TPX congruent to SMX. Do we think that's enough info to say it's a parallelogram? Because I think there's going to be some controversy here. I may have some yeses and I may have some nos. What do we think with those angles being congruent? Parallelogram or not? Just state your case here. 19. I got a no. Anybody think yes? So I do have some yeses in the house. Obviously, I have some nos in the house. Okay, let's discuss it then. Let's take the red angles I have here. The red angles. Here's a diagonal. Anybody know what type of angles these are? Alternate interior angles. And if they are congruent, what do I know about the sides from a past unit? These should be. If alternate interior angles are congruent, the lines are Parallel, yep. Okay, wait. What about the brown angles now? Those are what type of angles? Alternate interior. They're congruent, meaning the lines are parallel. Is this now a parallelogram? Yes. Why? Because opposite sides parallel imply a parallelogram. So watch out for that again. Diagonals in a quadrilateral. Hello, Justin.
Could you add them up and then say the opposite angles?
No, because if you added them up, that would only give me one pair. Remember what we said before? It's got to be both pair. Okay, good point. Good try, though. Anything else in your group right now or whatever your solo shot you're doing here? Go ahead, 7 through 14. You do not go, let's save some time and just give me a yes or a no. Okay, you don't need to explain. Just give me a yes or no to save some time so we can get to the proofs. Okay, so 7 through 14, based on those markings, is that enough info?